Good morning.
Hello, good morning, Josh. Can you hear me? Can anyone hear me? Okay, great.
Yes, I can hear you.
Okay, so, all right, you're all welcome. Let me share my video. Okay. You're all welcome to the JAG Ghana event that's happening today on the 26th of March, 2022. So Ghana JAG, hello everyone, and my name is Ya. I'm the co-lead for the Ghana JAG community, that's the Java user group community, and you are welcome to our monthly meetup in March. Ghana Java User Group Ghana is actually sponsored by Turntable, and we have most of us are members of the community. I'll be serving as your moderator for today. First, a brief word about the JAG community. Okay, so the purpose of JAG Ghana is to promote awareness of Java and associated technologies by hosting Java technology meetups for developers, students, and other professionals who want to ultimately focus on learning more Java technologies, share knowledge and experience with others, and also find new ways of using Java technologies to benefit the business industry. Okay, good news is that membership is free, and anyone with an interest in Java is welcome to our monthly meetings. As a means of continuing our expansion, we ask everyone here to extend a few invites, share the flyer, the poster on your social media feed, invite somebody. You can also tweet or write snippets of anything worth noting of during the event on your social media platform. And kindly share your takeaways on this event. And after the session, after the presentation with Josh Long, we'll have a Q&A session, so you can drop your questions in the chat, and he will definitely answer them as and when during the presentation. Okay, so these are our social media links and profiles. So on Twitter, we are as Ghana JAG, and you can find us on meetup.com, which is also the name is Java User Group Ghana. And then on LinkedIn, we are also Java User Group Ghana. Okay, so would move straight into, would not like to waste time at all. But then don't forget to leave your questions in the chat. This is going to be a very educative session where we learn more about Kubernetes native Java. So I would go ahead to give a brief introduction to who our guest speaker is. So our guest speaker is in the name of Josh Long. Josh Long is a very a very experienced contributor to the Java community in the world. He's a Java champion, and as we can see, he's been the first Spring developer advocate since 2010. He's an author of 6 books, so you can go check him out, including O'Reilly's book on cloud native Java, that's designing resilient systems with Spring Boot, Spring Cloud, and Cloud Foundry, and Reactive Spring. And he's also, he has numerous best-selling video trainings you can check out if you really want to expand your knowledge in, cloud native apps. So let me not go too much into this, but I'd like to introduce Josh Long and say a very big thank you for accepting our invitation to share more light on this topic. All right, so hi Josh, I'll definitely pass the mic to you right now and stop sharing my screen so that you can come on. All right, thank you.
Okay, thank you so very much. How do you say your name? Is it Ya, or
yes.
How do I? Is that the right way to greet you?
Yes, you can call me Ya.
Hi Ya, nice to meet you. I'm Josh. Well, everybody, I appreciate you making this opportunity available to me. I'm super excited to be before you all today. Obviously, I wish I could do it in person. It's been a weird few years, hasn't it? I hope you're all, happy, healthy, safe. It's not something you can take for granted these days, So I mean that sincerely. I am glad to be before you all today. It's 3 a.m. my time, but just today, my family and I we flew to Hawaii for a little holiday. So I'm in the island. So it's actually midnight where I am right now, even though my brain still thinks it's 3 a.m. because I just flew here from California, from San Francisco, where my family and I live. And either way, I can't think of a better thing to do at 3 a.m. than hang out with you all today and talk about how to build cool things with Spring and Java and all that. Let me share my screen here. Let's see here. Good stuff. So I understand that the predominant language there is English, yeah, but I've never been, unfortunately. I have not had the privilege of visiting. But I also heard that there's a push to get French as an official language. Is that true, or did I just read the wrong headline or something?
Please come again. I missed.
Sorry, I understand that English is the predominant language there.
In Ghana,
but I read, yeah, but I read that there's also a push to get French. Is that? Did I read the wrong headline? Is that not true?
I think about 80 to 90% of us speak English here in Ghana. So yeah.
Cool. Yeah, I live in the U.S. and we can scarcely be said to speak anything, but if we speak anything, it's probably something that resembles English. so at least we have that going for us, huh? Okay, well, anyway, good stuff. Thank you so much for having me. And by the way, I want to second what you said earlier, which is, this Java user group and other Java user groups around the world, they are so valuable. They're such a valuable resource, when I was younger, I mean, I'm not all that old now, I suppose, but when I was younger, I was lucky. My dad would take me to a bookstore, and you could buy a cup of coffee. I was all of 15, and we'd go in there and we'd buy a cup of coffee. And I didn't have the money. I couldn't afford to buy. Excuse me. I couldn't afford to buy these computer books. And back then, in the 1990s, 20 plus odd years ago, these books, as they do now, unfortunately, they cost a fortune. They were $50, 50 US dollars. I don't know what that is in your local denomination, but it was a lot, right? I couldn't afford a single book for $50. So I would go there into these bookstores, and I would bring a clipboard with paper and a pen or a pencil or whatever. And I would sit there and I'd just write down code and I'd read. I'd be this kid with a cup of coffee sitting on the floor, surrounded by stacks of books that I didn't own. I was just basically treating it like a library. And the people at the bookstore they knew me. At some point, they just realized I didn't mean any harm. I was just trying to learn. And I just think about that. I think about, I was very lucky, first of all, that bookstore didn't kick me out for loitering or for making a nuisance of myself. And then second of all, there were books, physical printed books that I could actually look at. Whereas today, so much of what we do, so much of the process is digital, right? And so there are courses and videos and all this that people put out, myself included, and those cost a fair bit of money. And so when I think about what we can do to improve the lot of people who are trying to get into the industry, I think, okay, well, we got to put things out there that are approachable for everybody in the same way that those books were accessible to me, because I could sit there and just learn from them. And I think of Java user groups. That's the one thing that, they're always free. You can always go to a Java user group almost anywhere in the world, except for maybe Antarctica. And you know what? There's probably one there too. I don't know, maybe those penguins are learning Java or something. I have no idea. But the Java user groups are just such a valuable thing, and they give people the opportunity to connect with interesting people. That's how I was lucky enough to get into this industry. I met people through my various local Java user groups. No matter what the city I lived in, I've always had that connection because they're just a great implement. And now this stupid virus, this terrible virus, it's the worst. But the one thing that it has given us is it has made it so that it's possible for people to come and speak at, different user groups all around the planet online, right? So now there's no cost to anybody except for some time. And I think in that one thing, that one solitary element, that one solitary aspect, it has been a benefit, a bit of a blessing, a silver lining. That's the right way to say it. A silver lining, right? Is that we have that ability to be closer to each other, to learn and to network. Normally, before the virus, I would try and get on a plane, and if I could be with you all in Ghana, I would. If there was any way to do it, I would have done it. But now, the world is so big again. It's so implausible to fly places and get far away and all that. So I'm just happy to be before you here today. My name is Josh Long. I work on the Spring team, as was just well explained. I am a Spring developer advocate at Tanzu. Tanzu is a division of VMware. The Spring team, we work on the open source Spring projects, and we are a part of Tanzu, right? We are part of a VMware. And VMware, we have a vested interest in helping to make the lives of developers easier. We want them to be more productive and to be able to deliver software, viable, reusable, viable, stable, scalable software into production. And not just quickly, but safely, right? Anybody can drive a car at top speed, but that's hardly safe or worth doing, right? You might only get to do it once after all. So what we want is to help people do so in a reliable, repeatable manner, so a big part of that is Spring. And if they can do that, then the next natural question they're going to have is, well, how do I operationalize that? How do I take that software and deploy it and get into production? And that, by the by, my friends, is I think the mark of a professional, of somebody who's gone into industry and applied their craft, right? Is can you take your software to production? Is it worthy of production? And these days, as often as not, production is Kubernetes. And obviously at VMware, we have a Kubernetes distribution called Tanzu Community Edition or something. I don't know. It's a Kubernetes distribution, and it's fine, right? It works great. But that whether you're using ours or anybody's, getting software running on Kubernetes is its own thing. There's a lot of concerns that sort of fall out of that. Those concerns are not unlike in some ways, they're not unlike the concerns that you will find when you try to build software intended for any cloud environment. And so there's just a lot of scenarios, a lot of use cases there, and a lot of patterns that sort of fall out of this use case of, I want to build software quickly and safely, and I want to get it into production. And so people look for ways to quickly and safely get software into production. They look at their organization and they realize that their organization, however wonderful it might be, is sometimes disjointed, right? Different groups in the organization work in different ways. They have different cadences at which they deliver software. They think about software in different ways. And this can be problematic because you might have developers that are working towards a sort of the goal of delivering software quickly. They're doing test-driven development. They're doing, continuous integration. They're doing microservices, etc. But then you have this larger organization in which those developers are set that may not think like that. They may be thinking more like a traditional waterfall sort of setup where they have, forecasts for 18 months out. We're going to have this software done in 2 years. And it's like, well, that won't work. That's not how software works, right? You can't know the future, and if you could, it wouldn't work that way, even if you could. So we see this a lot. We call this water scrum fall, right? Where you've got organizations that are like waterfall around the edges, but the developers are doing something approaching agile. So you got to fix that. First of all, it's a holistic discussion. If you're just developers and you're just working in one little pocket of the organization, and the rest of the organization isn't optimizing for continuous delivery, they're not optimizing for taking software into production as often as possible so that you can see the results of that deployment, validate what you have done is what the customer needed, and then improve. If you're not optimizing for that all the time, then you're gonna you're missing out, right? That's the goal here, is to go quickly so that we can improve, so that we can build a learning organization, right? And once you've done that, there's lots of patterns. There's lots of things that you can do when you realize that the goal is agility for the reason that you want to learn. There's a lot of things that you can do. There's continuous integration, continuous delivery, cloud computing, test-driven development, microservices, all this stuff. Really, if you think about it, there's nothing technologically all that novel about it, right? It's really more that these things are faster versions of things that we had 20 plus years ago. It's not like we didn't have a way to deploy software to a server 25 years ago. Certainly, of course we did, right? So long as there have been servers, that was the case. But the fact that I can now go to a web page, press a button, get a server, and then deploy software to that on every Git commit, that's what's interesting, right? The velocity of it. And that velocity gives us some opportunities. It gives us the ability to maintain a competitive edge in an industry where people are moving very quickly. They're designing, delivering, and innovating very, very quickly. So the goal here is to go quickly and safely to production. And so we're going to talk about that today. We're going to talk about a lot of different patterns that you should probably care about, or you might want to care about when building Java applications with Spring Boot. And I'll be your host today. I'll be your guest host. My name is Josh Long. As I said, I work on the Spring team in my capacity as a Spring developer advocate, a Kotlin Google developer expert, a Java champion. I have a book. I have called React to Spring. I have a blog. I have lots of stuff there. Most of my code is under github.com, Josh Long. But you'll find lots of other code at github.com spring-tips, which is the name of my YouTube series, which you can also find at bit.ly/spring-tips-playlist. I have a podcast every Thursday where I talk to people in the industry. And basically that podcast is a forcing function. Before the virus, I would travel. I used to do 1 million kilometers a year on planes. I would be on, 50 or 60 cities or dozens of countries every year, and six of the 7 continents every year. And I always thought, gosh, I get to have these really great conversations that are just so much smarter than I am, and I'm just so grateful that I get to learn from these people. I don't know why they've ever suffered me, but they do, and I've always appreciated it. And I always thought, gosh, if I could just turn on the microphone and record what they're saying, that'd be great. This podcast, I could just share. I just want to take these amazing hallway conversations to which I've, for whatever reason, become privy and share them with the world. And then the virus came, and now the podcast, already well into its 4th year, the podcast has served as sort of a forcing function, forcing me to instigate these conversations, because I'm no longer by happenstance bumping into these people. Instead, I'm using the podcast as a means to continuously stay engaged with people. So there's that. If you want to just listen to me learning from people by listening to them, then join me on the podcast. I'm on Twitter, I'm on LinkedIn, I'm on email, and I'm happy to answer questions at any of those channels. So if in our brief time today you don't get your questions answered, and as we just heard, I'll be doing a Q&A, and I really don't have all that much of an upper bound. I can stay later, of course. But if for whatever reason you don't get your questions answered this morning, then again, feel free to reach out to me on these channels: Twitter, LinkedIn, email, etc. Twitter more than often than not, right? But either way. Okay, so my friends, with that as the backdrop, let's actually talk about writing some software. We're going to do that, as always, by going to my second favorite place on the internet. Obviously, my first favorite place on the internet is production. I love production. You should love production. You should go as early and often as possible. Bring the kids, bring the family. The weather's amazing. It's the happiest place on earth. It is better than Disneyland. But if you haven't been to production, you can begin your journey here at start.spring.io. And what we're going to do is we're going to build a new application called Customers. I'm going to use Java 17, which is the current long-term supported version of Java. I think it's a suitable, safe, stable place in which to park your code. But that said, just last week, Java 18 came out. So it is now the current supported version of Java, right? And it'll so be for the next 6 months. So you have a choice. Do you want to stay on Java 18 and be poised to jump to Java 19 when it comes out in 6 months minus a week? Or do you want to just park your code for the next year or two on Java 17? For our purposes, since we're also going to be using GraalVM, I'm going to be parked at Java 17, but Java 18 is amazing. There's a lot of nice features there, including internet domain resolution, right? There's an SPI for overriding the way that the JVM does DNS resolution, which I think is just, the possibilities for that are just incredible. I can't wait to play with that a little bit. So we're going to use Java 17. We're going to use the reactive web and reactive R2BC for database access support. Now, reactive programming is an approach to building software that optimizes for the efficient use of threads in the system. It gives you a way to describe control flow to the system in such a way that you're never wastefully sitting on a thread waiting for something to happen. Okay, and we'll get into the details of that, but reactive programming implies three big benefits. The first of which is resource efficiency. That is to say, you put your threads to good use. It implies ease of composition because you have a single unified abstraction on which all sort of reactive code hinges. And three, because you have that single unified abstraction, you have a single place in which to interpose operators to support things like back pressure and rate limiting and circuit breakers and the like, right? All these things make your applications just that much more robust and production proof, okay? So we like reactive programming. I'm gonna use the reactive web support. I'm gonna use H2, which is an in-memory embedded SQL database. And we'll use R2BC, which is our SQL, it's a SQL abstraction. We're gonna use Spring Native, right? I wanna turn my application into a GraalVM native image. So we'll look at that. And we're gonna use a Spring Boot actuator, all right? So we're gonna go ahead and hit generate. And the actuator, by the by, it supports operations, observability, right? So we'll use that. So okay, UAO customers.zip. Let's go ahead and open this up in our IDE. And I'll drink something. All right. Let me make the font a little bit larger. I'm sorry about that. 22, voila, okay. So there's our brand new public static void main application. What we're gonna do is we're gonna write an application that writes data to a database, data that we're gonna describe in terms of a Java record. I don't know if you've had the chance to play with records, but these are amazing. It's just a type that has, well, here, you can see it here. Var customer equals new customer, right? So it'll be Josh, whatever. And then if I do that, I can say customer.id, customer.name for free by using that syntax. It's kind of like case classes in Scala or data classes in Kotlin. It's just a very concise way to describe data in which the fields in the class are the sum of the class, right? They are the identity of the class. Okay. So we're gonna have a type there. We want to write data to the database. So I'm going to create a repository. A repository is a design pattern that's designed to insulate your business logic from the low-level read, write, update, delete sort of lifecycle stuff that you have to do. This repository, because it's it's a Spring data repository, it has methods like find all, save, count, flush, delete, etc. These methods are implied by the interface reactive code repository. Spring Data will provide an implementation. So you can ask Spring Data to give you a reference to this customer repository, and you can then use those methods. You don't have to actually implement them. Spring will do that for you for these types, customer and integer. All right. Okay. So we've got the repository, we've got the customer, and I want some sample data, don't I? So I'm going to go here. I'm going to say source main resources. I'm going to create a new file here called schema.sql. I'm going to create a table, a schema table, and this file, schema.sql, Spring will read it into the application when the application starts up. It'll read it into the database rather. So what we're doing is we're creating the schema for our data, and then we're going to create some sample data and write it into the database. So we'll say insert into customer ID serial primary key name var car 255 not null. Oops, so what am I doing? Insert into customer name, and then I'm going to put the names of different people. Okay, so since we have you here, can I get some names?
Yeah, you can use yeah. And
Like
Francis.
that? Francis, like this?
Yeah, Emmanuel.
Is that like that?
Yeah.
Josh.
Yeah, Josh.
Yeah, okay. All right, well, okay, that'll do for now. If you want to give me some more, I'm happy to add them. So we got 4 names now. And I just want to see that that has worked. So we'll say application runner. I'm just going to create a little Spring Bean that when the application starts up, will, it'll run. It's just an object that has a callback. It's a lifecycle. So I'm going to say subscribe. I'm going to say find all, and I want to get the results. I'm given a sort of like a future, right? Except that instead of just one value, you get all the values, 0 to n. So this is returning something called a flux. A flux is a reactive stream. It's a publisher. Okay. So let's just run this just to prove the absolute basics about our application. Just make sure all the, sky is blue and the application is working. Let's see, where's my Spring Boot? Okay, main. Not sure why. Sometimes IntelliJ just forgets where the main class is in the application. Okay. Very good. So it looks like it's worked. That makes me happy. Let's just run it one more time. Goody. Okay, so there's the application. It's worked. I want to create an HTTP endpoint to expose that data. Yeah, so I'll say class customer REST controller private final customer repository, and we'll say at get mapping customers publisher flux customer git, yeah, and we'll say customer repository find all, and voila, there's this. So it's going to be at response body and at controller. These annotations tell Spring that this is a HTTP endpoint and that the return value of these methods, each controller handler method, should be used to provide a body, to be rendered as JSON. Okay, so as opposed to the default behavior, which is when you return a string, Spring will it'll attempt to resolve a view, like a HTML server-side rendered view, right? Okay, there you go. So there's our data. It's worked. Of course it's worked. It's a demo, right? It was gonna work. But this isn't what we wanted to do, right? We built an application. That's fine. It's not all that big a deal, right? But are we ready to go to production yet? And I would say at this point, not quite, right? We need to support observability. So one way we can do this is to use the Spring Boot Actuator. This is a module that, when on the class path, exposes information about the application proper. It exposes health information, metrics, etc. So I'm going to tell the actuator to expose all the endpoints so that we can, for our demo, and only for our demo, because you wouldn't want to do this in production, so that we can see everything that's happening there. I'm going to show all the details for the health endpoint. I'm going to enable Kubernetes probes. And I'm going to, I think that's it for now, actually. Let's just leave it there. So let's go ahead and restart. Okay, localhost customers, good, it's still working. Now we go to /actuator. What's that? What's this? Go to /actuator, and you see we have these different HTTP endpoints. I've got a pretty printing JSON plugin on my browser, so that's why you can see this hierarchical data, but it's actually just regular JSON data. So if I go to the beans endpoint, I can see all the different Spring beans, all the different objects and how they're related to each other in the Spring application context. The scope of the beans, it's a singleton, there's only one of them. The type, the literal class file, the dependencies, the other types on which this type depends, etc., for it to be a valid, fully formed object. And that's all very good because it shows us, the makeup, the composition of our objects. We have the caches endpoint, which shows me all the different cache managers. So if you wanted to defer to something like Redis or Hazelcast or, Apache Geode or whatever, then you would see that implementation here. The health endpoint gives you information about the different subsystems in the application that were they to fail, would imperil the state of the overall service. And so these gives you information like, is my database up and running? Well, it looks like it is. There's a validation query that returned in the positive, so we know that's working. My file system is still working, right? So there's a lot of different things here. But if any one of these were to fail, then the aggregate status here would also reflect that. So if this were to say down, then this would also, the overall aggregate status would also reflect that. It would say down as well. We're going to come back to the health endpoint, but suffice it to say, this is critical this is a critical endpoint because you want your platform, your cloud technology, whatever it is, be it Kubernetes or something else, to have a way to know whether your service is healthy or not. Because if your service is healthy, it needs to be taken out of rotation and replaced. We'll come back to that in a second. We've got the info endpoint. The info endpoint is just it's information that you can use to understand the application proper. So you can put arbitrary information in there, like I can say info endpoint enabled true, and then you can put info dot message, hello. Come on, Josh, you got this. Okay, good. Right, there we go. So I can restart with those settings specified. Okay, and you can see we've got a message there. Great. Another thing I can do is I can put information about the build, the Git commit that triggered the build that we're seeing here deployed into production. And you can do that by using the Git Commit Id plugin. So I can take all this, go back to my build, go down to the plugins down here, and I'm going to replace it with this plugin. I'll just add that. And what I'm going to do here is I'm going to stop my running application. I'll recompile it. I'm going to turn this into a Git repository first. Git init, git add, git status, git add.mvn, git add, git ignore, git commit gi. Okay, good. Git status, good stuff. So Maven clean package, yeah, and just save a few seconds here. Alrighty, so we're going to restart, and that done, you can see now that there's information about the current branch of the code, right? So imagine this. Imagine you have continuous integration. Somebody has checked out the continuous integration tool has checked out your latest commit. It's Git cloned it to the local machine on some CI server somewhere. I use GitHub Actions because it's free and it's easy and it's amazing. And it'll then build the code, run all the tests and all that. And then if everything goes to plan, hopefully at the end of that continuous integration run, there's some sort of handoff, perhaps to a continuous delivery service like FlexCD or Argo, or maybe you just deploy directly to your platform there. But either way, it goes from the CI environment to production, perhaps via that CD tool or just perhaps directly. And when it goes to production, it can be hard because you might have 1,000 Git commits every day. You might have 1,000 new builds that get promoted to production, particularly in a continuous delivery context, every day. And so having the ability to go to the Actuator endpoint and say, oh, okay, this is this version of the code, and I can trace that back. I can say, okay, look, Josh changed something. Of course, it broke the build in production. He didn't write a test. We didn't catch this. We'll go talk to him and we'll get it fixed, right? Not a big deal, but you need to know which version of the code is running there to see where the bug occurred. Okay, so info, I love that endpoint. Let me get rid of this because it's cached otherwise. And then we have the conditions endpoint, which shows me all the different conditions that the application evaluates to result in the application that you see before you. So when the application starts up, it evaluates a bunch of tests. Is this class on the class path? Is this property specified? Is this object in the application context, etc.? All those tests taken together result in the application that you see before you. If you want to understand what tests were evaluated, then you can look at this conditions endpoint, right? It's very, very important to understand how you get the behavior that you see, right? We've got the config props endpoint that gives you system properties and things like this. So this gives you all the different properties to which your application will respond. So suppose I wanted to configure things relating to my Actuator management endpoint, right? We can see here that I can configure management.endpoints.web.pathMapping or management.endpoints.web.exposure.include. And you saw actually I did that just a minute ago, didn't I? So management.web.exposure include equals asterisk, and you can see the current value for that. So this is great to see what properties are available to you to override the default behavior of the Spring Boot application. We've got the env property, which gives you system properties and environment variables and all that. Mercifully, if you have like properties that are like --password or secret or whatever, those get masked. They're replaced with stars, asterisks. But nonetheless, this is great to understand what properties are in the environment in which the application is running. We've got the loggers endpoint, which shows you all the different loggers and their log levels, and you can actually post to this endpoint to override the different log levels for particular things. So if there's some sort of outage and you want to debug why certain code and a certain code path is running astray, then you can change the log level to a different granularity, maybe debug granularity, to better get better errors to perhaps guide your attempts to understand what's happening. Heap dump and thread dump, well, they're pretty self-descriptive, right? They provide a heap or a thread dump that you can then evaluate. Providing the heap dump, you can put that into a profiler, for example. Metrics gives you keys and values or statistics about your application. So, for example, http.server.requests is a count, is a statistic around how many requests have been made to the HTTP server, and you get different statistics. You get the count, which is the aggregate. You get the total time. You get the max of all the different times. You've got different dimensions of the data. You can say, okay, I want to show all the different requests where the exception that I got was either none or response status exception. I want to show all the requests where the method equals to, well, in this case, just Git, but perhaps something else, or all the requests where the URI is one of these, right? Etc. So you can break this statistic down even further by saying I want to see a different dimension of the data. I want to see this statistic, but only in terms of those that match a certain predicate. Okay. Scheduled tasks is obviously if you have like a Spring's @enable scheduling mechanism. If you have that activated and you're doing like scheduled jobs in the background, something that executes every second or whatever, then you would see that here. And of course, mapping gives you an enumeration of all the different HTTP endpoints exposed to the open web. So if you want to know what HTTP endpoints your application will respond to and what components power those HTTP endpoints and what verbs they accept and all that, then you'd specify all that here. Okay, so we've got all this good stuff, right? Now let's go back to that health endpoint. This health endpoint, like I say, is it's a great way for you to articulate the state of the service, because again, who better than your service itself to articulate its own state? If you ask your container orchestrator like Kubernetes or Mesos or Cloud Foundry or whatever, they can, at best they can look at the RAM and the CPU and what all, but they can't really understand what your application is doing. They don't know that your queue depth in RabbitMQ has exceeded some safe level, and therefore the service should be considered unhealthy because it can't possibly fulfill the requests that are going to be placed on it, right? So this health endpoint is a great way to articulate that information. Kubernetes in particular, however, has two different health checks that it cares about. One is called the readiness probe. The readiness probe tells Kubernetes whether the service is ready to be put into production. The second one is liveness, which tells Kubernetes whether the service is still fit to be in production. Now, suppose that liveness, for whatever reason, returns that the service is sick, right? And you can actually control that. You can, let's say I can do a health controller here, and I'll do @response body, and I'm going to inject a application context reference here, like so. And we'll say post mapping down mono void down. So what I'm going to do is when somebody calls this endpoint, actually just make it easier, just make it a get. It's just a demo after all. When that happens, I'm going to receive an event. So application event publisher, sorry, application ready event dot application. What am I looking for here? Event application context event, something like that. There's a for whatever reason, I am trying to. I'm having trouble remembering application ready event application events. Oh yeah, availability chained event dot publish. There you go. So this dot application context, and the thing that I want to publish is that the liveness state is now broken, right? So what I'm doing is I'm publishing an event. When somebody calls this endpoint, it's going to publish an event in the Spring application context. Think of the application context as kind of like an event bus. You publish any component, any Spring Bean can inject a reference to an application event publisher, or just get a pointer to the application context as we did here. And they can use that to publish an event. So .context.publish event, new, something event, right? Whatever, new application ready event, right? You can put, and you can create your own event, any event, if you want. You can actually extend at the root this type called application event. Now, application event is a base type. It's a type that you can use to create your own events, and you can communicate them asynchronously to other components in the application context. So here I am publishing, I'm using the static method that all that does behind the scenes is it publishes an event that signals to the probe that the service is down. So let's go ahead and try this. We'll restart. Okay. So curl localhost. Okay, 8080/down. Okay, so if I go here, now it says down, right? By default, I should have started with the default view first. I'll restart. Okay, so by default it's up. Go here, call that. Go there, it's down, right? So you can actually you can signal that this probe, this endpoint, is now down. When that happens, Kubernetes is going to see that and it's going to, oh, okay, something's wrong. And then the question is, what do we do with our service now that something is wrong? Well, the container orchestrator is going to shut the service down. It's going to kill the instance of the application deployed in Kubernetes. The smallest granularity deployment unit for Kubernetes is something called a pod. A pod is an aggregate of one or more containers, right? But you can't really talk about individual containers in Kubernetes. You have to talk about a pod that contains a container or more than one container. So the container orchestrator is going to kill that instance for us and then start up a new instance. The question then is, what happens to the instance that if it's got in-flight transactions? So for example, I want it to shut down gracefully. I don't want it to kill everything in flight and then just drop all the state on the floor. No, I want it to wait until I've tapered off any in-flight existing transactions, and then, and only then, kill the pod itself, and then create a new instance. So we can make sure that happens with graceful shutdown, which will automatically stop accepting any new HTTP requests, and it'll let you kind of finish anything that's in flight, and you can do so within a certain period of time. So let's say 30 seconds. You need to make sure to coordinate that timeout phase with your Kubernetes configuration though, okay? Okay, so we've got our application. It's up and running, and we've got these actuator endpoints, and we looked at different ways to configure them to respond well to changes in the cluster. Some of this configuration, however, we've done through this application.properties file, and you can see that some of it is very much Kubernetes specific. These probes, for example, this is Kubernetes specific. And this configuration might be best configured only when running in Kubernetes. And so the Spring Boot has this special syntax hash triple dash that allows you to describe stanzas of configuration. So this configuration, all this stuff up here, is general purpose that applies to everything. But here, after the hash triple dash, I can specify configuration that only lives, that only gets run in Kubernetes. And I can do that by specifying an activate on something. So activate on cloud platform, activate on profile, etc. So on cloud platform equals Kubernetes, etc. So very good, right? Spring config activate on cloud platform. And I can do, let's try it out. I can actually, oops, hello. Okay. I'll do, we're going to do something specifically for Kubernetes. So I'll do YAML, okay? We'll restart this. Now, by default, it's going to give us hello, but, whoops, what did I do there? Oh, the probes. Oh yeah, the probes don't exist anymore because it's not running in Kubernetes. It doesn't think we're running in Kubernetes at the moment. So that's the first thing. And then if I go to info, it says, hello, Jug. Now we can teach Spring Boot. We can make Spring Boot act as though it's running on Kubernetes by specifying this platform, this property, right? So I'm going to say Spring main cloud platform equals Kubernetes. We'll go here to edit configuration, modify options, and we can go to the program arguments, and I'll specify -- Spring main cloud platform equals Kubernetes. Hit OK, and then I'll restart. Okay, there we go. And there you go. It sees it now. It thinks it's running inside of Kubernetes, and so it gave us a different message. All that to say, you can have configuration sets that belong specifically to a particular platform, and you can do the same thing with your Spring Beans, right? I can actually have, let's say I wanted to have another message, another application runner on Kubernetes. Return args hello, Kubernetes. This will be a Spring Bean cloud platform dot Kubernetes. So restart that. So you can see it says hello Kubernetes, but if we go here and change this, hit apply, hit OK, reload. You can see it doesn't run that anymore. Okay, good stuff. So we have dynamic configuration. I might want to source my configuration from Kubernetes itself. In Kubernetes, you have this concept of a config map. A config map is it's a map of keys and values. The keys are the configuration keys, and the values are the configuration values, the secrets, the whatever. That stuff you might want to use inside of your application. And so you have to take that config map and make it available to your application in one of two ways, either as an environment, in which case the config keys become environment variables, or as a config tree, which is a volume, it's a directory where each of the files in the volume is, the file names correspond to the keys in the config map, and the contents of the files correspond to the contents of the values in the config map. Okay, so config map becomes environment variables, or config map becomes files in a directory. Either way, your Spring application should know how to read them. And Spring Boot knows innately, since 1.0, what to do with environment variables. So for example, if you say server.port, server port equals 8010, let's put that over here. That's one way to configure it, but did you know you can also create environment variables like that? So I did export server underscore. I'm not sure if you can see it with the little squigglies there, but that's an underscore there. Export server underscore port equals 8010. Put that in the shell script that runs your application, or and in some way expose it as an environment variable, which you can do on Mac, Linux, Windows. All operating systems have a way of doing environment variables. If your environment variable corresponds to a property that would be in application.properties, it overrides the property value in the config file. So that's one thing that works out of the box with Kubernetes. But there's also a different kind. Like I say, you can mount a config map as a volume, and that becomes what we call a config tree. So let's say if I'm running in Kubernetes, I want to import config tree configuration. Okay, so I'll get configuration from the home directory /config, and let's see, desktop config. I don't have it yet, so make dir config cd config echo 8181 to a file called server.port. Okay, so I'm here, desktop config. Home is an environment variable for user JLong, and then desktop config, right? So that'll be the import. Let's go ahead and see what happens if I bring that in. It should run the application on a different port now. The default, of course, is, and always has been, 8080. Config tree 8080. What did I put in there? 8181. Did I take away the Kubernetes program argument? Oh, I did. Haha. Okay, so it's okay equals Kubernetes. Take 2. Okay. So now it says it's starting on port 8181. So it drew that configuration from this config tree, which is a very common thing in Kubernetes. So Spring Boot knows about both of those types of configuration. Okay, so now we've got our conditional Kubernetes in contextual specific configuration. We've got our application, we've got it talking to a database, it's reactive, it's, it's great. Let's get it to production. And there are 2 concerns. One is I need to containerize it. One thing you can do to containerize your applications is to use something like build packs. The core conceit of build packs is that there are only so many different ways to do Java minus jar. The fact that we all reinvent that particular recipe of taking an application and running it in a container in a Docker image is just mind-boggling, because there's only so many permutations of how to do this. Why are we reinventing that particular wheel? There's no innovation there. It's just Java minus jar. There's no art to it. So this project, build packs, makes it trivial to take an application artifact, be it a .jar or a .war, or a .NET exe or a Go program or a Ruby on Rails program or a Python Flask or Django or TurboGears application or a Sinatra application or a Node.js npm application, whatever, right? Any kind of application you can imagine, there's probably a build pack, and their build pack is in effect a recipe to take an application artifact and create a container that can run that artifact. So .jar in, container ready for production out. And so this is useful. You can actually download a CLI called pack, and you can use that to create containers. Spring Boot also has support out of the box in the Maven plugin. So you can do Maven Spring Boot :build-image, and that'll give you a Spring Boot application that runs in runs on the JRE within a Docker image. And that's already useful in of itself. But what I want to do is I really want to turn this application into something more efficient. I want to take advantage of something called GraalVM. GraalVM is a OpenJDK. It's a drop-in replacement for OpenJDK. And you can use it just like any other regular JRE if you like. It's got a replacement for Hotspot. Now, Hotspot is the world famous, notorious, amazing, ahead of time optimizing compiler. It takes your code, your Java code, and turns it into operating system specific, architecture specific, native code, right? Binary code. This code is not portable. You can't run it. You can't run it anywhere. It only runs on the operating system and architecture to which or for which it's compiled. But it is very fast. It takes up a very small footprint, and it's really, really fast out of the gate. So it's a good deal if you're doing cloud deployments where your application footprint can be sizable, and the reduction in footprint is so significant, in fact, with this that it really changes the cost dynamics of what it means to deploy an application or service into production. Your typical Java application might take 512 megs of RAM, right? And that's if you're lucky. And a lot of that, of course, is just the JRE itself. The JRE is amazing, but there's a lot of moving parts, and it takes a lot of RAM, which is great for server-side applications that are, you start them and they stay running for a long period of time. But for serverless use cases, for just in general, when you're trying to reduce memory footprint and RAM and disk and all that, it's just not great, right? We can do better. So GraalVM native images offer a compelling solution. So what we're going to do is we're going to turn our application into a GraalVM image, but unfortunately, the process is not as straightforward as it should be, because Java, for all of its stodginess and its warts, it actually has a lot more in common with the likes of Ruby and Python and JavaScript and Perl and Lua and what all than it does with the likes of C and C++, right? It's actually a very dynamic language. It has a runtime like Lisp and Smalltalk. You can actually change the runtime through the language, right? And so you can do some amazing things with Java. You can actually start an application, have it run. An hour after it started running, you can actually have the Java application with a Java string. You can take a string variable that has as its contents the definition of a class file, class, capital C, lowercase at, curly bracket. That's a valid class definition, right? For a cat. You can take that string, compile it again while the program is running. It can compile more of itself, right? It can compile another thing while the application is running. Then you can reload that type into the class loader. Then you can create an instance of it reflectively using Java reflection. Then you can proxy it using JDK, invocation handlers and proxies. You can serialize it. You can do all sorts of things to this type and never ever have a type that you can see at compile time, right? All of this would be done after the application is started up, and it would be done in terms of Java lang object and reflection types, right? You'd never have a concrete type. And this is a problem because the way that the AOT compiler works is it looks at your code and it determines what in your code is reachable. That is to say, what code speaks to other code, what code interacts with other code. If my code calls this method on this class and this other package and this other jar, then we can say that method in that other class and that other jar is reachable because there's a direct connection between what I'm doing and what it's doing. But if you're creating a brand new class from whole class at runtime, then the compiler can't possibly see that. It can't see any of those things, right? And so we have to tell it about when we do those things. And the reason we have to tell it that is because if we don't, it's going to throw away all the types that it thinks we don't need, including those that we might be trying to create reflectively instances of at production runtimes, right? So the reason it throws everything away is because it makes the application more efficient, right? It throws away all the stuff that it considers we don't actually need and we don't use, which is a good idea, right? It actually is a very useful thing to do to your code base because it trims down the resulting binary considerably. If you're not using, the Corba types in the JDK, why are they on the class path? Why should you have to load them into memory? Why are they all there in my container in the first place? Ditto for AWT, the graphics library that's been in Spring since the very first early days, 25 plus odd years ago, right? That stuff is great, but I'm not using it. I'm building a server-side application. If I'm not using it, I don't want to pay for it, right? There's just so many things I just don't need that are in the JDK, and I'd like for my resulting binary to not have to suffer the costs, right? So what the AOT plugin does is useful, but we still wanted to keep certain things that it may not understand or appreciate we will need at runtime because we're not deterministically using that stuff and it can't perceive that at compile time. So we need to provide configuration. And GraalVM has a dynamic SPI you can use. It's a programmatic SPI. It's not very intuitive, but it's there. But most of the time, people they provide configuration files, JSON files. These JSON files have definitions of the types that are going to be used for serialization, for reflection, for proxies, for JNI, for all sorts of different things there. You have to provide configuration files to enumerate all those things that will, that GraalVM can't possibly see at compile time. If you do that, then the resulting binary is amazing. So somebody's got to do that though. Remember, the Java ecosystem is vast. Spring is vast. Just a couple days ago, 2 days ago, on the 24th, Spring, we celebrated the 18th birthday of the very first release of Spring Framework 1.0, right? So in 2004, on the 24th of March. So Spring 1.0, GA, the first GA version of Spring. And that itself was more than a couple years old before we ever released it as a GA thing, right? So, if you consider that Spring is, getting on past 20 plus odd years, the very first commits into Spring were in 2001. What would become Spring, where they were in 2001. So it's actually in that, if you measure it by that number, it's more than 20 years old. So the ecosystem that's been built around it is also dynamic and huge, right? So we got to be careful when we try and use AOT. We have to make sure that all this stuff that takes advantage of that dynamic behavior that Java has let us take advantage of, that still works. And so we have a project called Spring Native. Spring Native makes it easy to feed that configuration into the GraalVM compilation process, hopefully without your intervention. Now, bear in mind, I'm going to show you Spring Native today, but we are at a interesting point in the evolution of Spring, because Spring Framework 6 is just around the corner. Spring Framework 6 is due out later this year in 2022, and it'll integrate a lot of the work that Spring Native does to make building native images easier into the core Spring Framework. Now, I can't tell you that what you're going to learn here will be exactly the same by the time Spring Framework 6 comes out. It might well look a little different. But conceptually, I think things are going to be basically the same. You might see a few packages or methods here and there, or classes, whatever, change, but conceptually, the core ideas will be there. So we've got Spring Native on the class path. I didn't have to do anything to get it there. It's on the build class path. You can see Spring Native, and there's a Maven plugin down here. The Spring Boot Maven plugin has been configured to create a small container images. We've got the Spring Native AOT Maven plugin that's there. So all that's there. What I'm going to do is I'm going to build this application. I'm using GraalVM. So if I do Java version, you can see it says GraalVM CE 22.2.0. I can do Maven P native D skip tests clean package, right? Oops. So we're going to let that run. That'll take about a minute. I don't know how long. Maybe 90 seconds, maybe a minute. I'm running on a Macintosh. The process is fast, but it changes from one operating system to another. So your mileage may well vary. The resulting binary will be super svelte. It'll take up, maybe 50 megs of RAM or something like that, maybe 100, who knows, but very, very small comparatively. If your typical application takes up 500 or a gig of RAM, the idea that you can deploy the same application for 50 megs of RAM is just, so good, so good. So it's certainly something to strive for. We'll let that finish. It's nearly there, I think. Nearly. Well, it seems to go by faster when I'm doing this by myself, because of course there's Reddit and there's always a cup of coffee to go make or something like that. But it does take a crazy amount of time. Okay, 1 minute and 15 seconds. Target customers. Yeah. Oops. Allow this. So let me try that again. There you go. So that took 80 milliseconds, or 80 thousandths of a second to start. And it's embedding a complete SQL 99 database. It's got the embedded web server. It's got all of our business logic, and so on. And even better, if I were to look at the cost of that, let's say pgrep is it's called customers, right? That's the PID of that. So PID equals, and then bin RSS by PID, and I'll use this PID here. So it's taking 100 megs of RAM. This number will be much less, I think you'll find, on Linux, right? Typically these applications, on other operating systems are even more efficient, more svelte. But still, 100 megs of RAM compared to 500 megs. So that's a 5x reduction in cost, right? That's a big deal. That could change your cost dynamics about whether this service is cost effective enough to be worth developing and deploying. If you know you can get it done for a fifth the cost of data center spend, that's a big deal. Okay, so we've got our application. It's just a single service, but it's an application. It's up and running. Let's see here. We got this. Close this. close this and that. Okay, so we've got our application. Let's go ahead and start up an instance of that. And then we're going to build another service to talk to it. This is our customer service. I'm going to build yet another microservice here by going to start.spring.io. And here we're going to build an orders service. We're going to use RSocket, which is a binary protocol that was created by engineers at Facebook, or sorry, Meta, to get around some of the limitations of HTTP2 and gRPC and the like. Okay, so I'm going to hit generate. CD downloads, sorry, drive live UAO orders.zip. And we're going to build a binary application using RSocket, just because, you know, they're both reactive protocols. HTTP, it works well with reactive, but RSocket truly is reactive. And so I'm going to say, okay, class order controller. And we're going to just create a map of all the orders. Okay, we'll say at controller, at response body, create a type here called order ID, integer, customer ID. So it's just a microservice with data related to the orders for a particular customer. The first service manages the bounded context, the domain of the customers, right? This one is just a trivial toy example that has an in-memory list of customer data. So for var customer ID equals 1, customer ID is less than math dot random times 100. Okay, I plus plus, oh, sorry, customer ID plus plus. Ready? So there's this, and I'll say this dot db dot put customer ID. We're going to create a list. So we're going to say var list of orders equals new array list order. And we'll say list of orders dot add new order. And we're just creating some sample data here, my friend. So customer ID on the left, and then the order ID on the well, actually, I guess they're both the same number here. It doesn't actually all that much matter. So this dot db dot put customer ID. Wait a minute, what did I just do there? Okay, sorry. So what we want to do is we want to create a list of orders. So list of orders equals new array list of order. And we want to do that for each customer. So for var customer ID equals 0, customer ID is less than 8, customer ID plus plus. Okay. I think it's less than or equal to 8, just in case. And now we've got each customer. This.db.put customer ID list of orders. And then here, this is where we're going to create the list of random order data. So for order ID equals 0, order ID is less than or equal to some number that's, we're going to just math random it, right? And then order ID plus plus. And then it'll be a list of orders dot add new order. So customer ID on the left, sorry, order ID on the left, customer ID on the right. And here we've got a list of orders. Okay, so there's my updated code, just some sample data, and I'm going to make that data available over this binary protocol called RSocket. So I'll say whenever somebody goes to get the orders by customer ID, they can call this handler to get the data. So get orders for destination variable integer customer ID. And return this.db.get get customer ID var orders equals this, turn flux dot from iterable orders. Okay, good. So get the orders for this customer ID. This is a simple controller. It's another kind of controller. You saw me create an HTTP MVC controller or REST controller earlier. I'm now creating an RSocket controller. This is going to run on port 9191. Let's spin this up. So now we've got two microservices. And what I really want to do is I want to create another microservice that consumes that data. So I'll go back to start.spring.io, and I'm going to build a new service called the Edge service. And this is going to use Spring Cloud Gateway. It'll use the RSocket support. It'll use the reactive web support, and it'll use the Spring GraphQL support, the new Spring GraphQL support in Spring Boot 2.7. So we'll go ahead and create that, use Java 17, and hit generate, okay? So Edge, and an Edge service is just that. It's a service that lives at the logical edge of the architecture. It is the first port of call for requests coming in from the outside intended for the downstream service. So as requests come in from different clients, be they iPhone or Android or iPad or PlayStation or Xbox or TV or refrigerator or your smart car or whatever, as these different devices come in, they have different, bugs and inconsistencies and protocol and bandwidth constraints and security constraints and all that. And so your job is to make it possible for all these fairly homogeneous services downstream to accommodate all these heterogeneous requests coming in from the outside world. You filter them through this Edge service, which adapts the requests in the way that's required to allow them to work in the system. And there are several patterns that we're going to look at in that to that end. So the first pattern we're going to look at is an API gateway, and we can do this using Spring Cloud Gateway. An API gateway is great for stuff where you're not trying to override the semantics of the payload. You're just trying to act on the envelope of the payload of the message. So things like headers and protocols and that kind of stuff. So with Spring Cloud Gateway, you describe routes. Routes have a predicate. Let's say the predicate is to any request coming to this microservice, this Edge service, any request coming to 9999 with a path of .proxy. We want to send that to the downstream customer service, right? So customers. Okay, that's a very simple example, but you can kind of see what that does. Okay, now I might want to act on the request, right? Because after all, if they call / proxy, Spring Cloud Gateway is going to take the incoming request, and it's going to take all the attributes about the incoming request, and it's going to send that same request with all the other information to the downstream URI that we provide. Well, obviously, / proxy is the path in the incoming request. Therefore, the outgoing request, the one going to customers, the one that's going to be proxied to customers, if Spring Cloud Gateway is just following the rules, it'll try and call this endpoint, customers / proxy, which doesn't exist. So we want to use filters to change the downstream path. So given a request coming in for / proxy, change the path to / customers and then send it to this host and port. When we're doing that, we can create filters. We can configure the filters. The filters are where the real power is in Spring Cloud Gateway. I can add a response header. I can say HTTP headers dot, access control origin. So now I can do cross-site scripting, that kind of thing. Let's go ahead and see what that looks like. Curl -v -u, curl HTTP localhost 9999 / proxy. Oops. What's going on? That's a new bug. Okay, let's try this again. Right. Localhost 9999/proxy to localhost 8080. Is that server up and running? It is. What port's it running on? Oh, it's on port. Okay, it's on the wrong port. Remember, I'm still running it as Kubernetes, so it's running on port 8181. Hit apply. Hit OK. Restart. There we go. So I went to localhost 9999/proxy, and that in turn sent the request basically, unchanged to the downstream service at port 8080, the customer service. So I got the customer data back, and that works great because now if you have downstream services and you want to just make that data available to your client, great. This is, again, I'm not acting on the payload of the request itself or the response. I'm acting on the envelope of it, right? I can add headers. So if I do that, I can see -v. You can see it says access control out origin is equal to asterisk, which is the header that we contributed in our filter pipeline. Spring Cloud Gateway is great for that kind of thing. But sometimes you might want to create a new view rather than just proxying data otherwise unobstructed or otherwise unmodified. Rather than doing that, you might want to create a new view of the data, right? And the reason you would do this is because your clients, they might be bandwidth constrained. They might be operating in a context where it's not efficient for them to make multiple calls to multiple network services, right? You just want to reduce the load that the clients have to bear, right? If you're building Android devices for people out in far-flung corners of the planet where cell phone signal might not be so good, then the last thing you want is for those Android devices to have to make 10 different network calls to get the data back. It's much faster to make those 10 calls on the server side in the cloud and just compose the data in such a way that the client can use it in one fell swoop. So this is a good idea, and reactive programming is great for this kind of stuff. So we're going to create a client here called CRM client. And in order to do this, we need to, of course, get the HTTP data, right? Oh, this is the order service. Let me go back, wrong one. Take this to the edge service. Here we go. Okay. Good. And we're going to need the, let's see, web client. Final, and then it'll be final RSocket requester, RSocket. Add this. Okay, so we want to get all the customer data, right? So get customers. And I'm going to create a client-side representation of that type so that we don't have to worry about serializing it into a different shape. Let's say this .http.get.uri HTTP localhost 8080/customers. And as the body of the data comes back, I want to unpack the JSON into a type, into a reactive stream of type customer. Okay. Now, what about the, oh, this is the wrong type here. What about the RSocket data? Well, here, when I get the data back from that service, we'll create another wrapper called order. And this is integer customer ID. And here, order, get orders for integer customer ID. So return this RSocket route orders customer ID, pass this in, retrieve flux order class, etc. Okay, so I'm making a RSocket network call to get the order data. I'm making a HTTP call to get the customer data, but these things are related. And so what I want to do is I want to compose a new view of the data, to create a new view of the data so that the client doesn't have to figure out how to call these two different services that are different protocols. And so that it can do it all in one HTTP request, right? One request from the client to the cloud, and the cloud will handle scatter, gather, service, orchestration, and composition. And so I'm going to create a new type called customer orders. And this will have on the left, the customer, and on the right, an aggregation of all the orders. Okay. So now I want to create a new endpoint that gives me all of that. So customer orders, get customer orders. Turn this dot get customers. So for each customer that comes back, right? For each customer that comes back, I want to turn it into, I need to call the order service to get the data. So I'll say that on the left, we have the customer data, but on the right, I need to get the order data. So customer.id, I want to collect all that as a list. And then that's going to give me a stream, a reactive stream of tuples where T1 is the customer and T2 is the order. So I'll turn that into the type that I promised in the contract, right? So tuple 2, get T2. Okay, so I'm building a reactive pipeline where I'm saying, give me all the data for each record that comes back, capture both the customer data and the order data for that customer in one type called a tuple, and then make it easy so I can map that tuple into my aggregate DTO here called custom orders. Okay, let's restart this and see what that gives us. Well, actually, we need to use that, don't we? So, we can easily create a new HTTP endpoint here. Okay, class customer orders REST controller. Final CRM client. And we're going to have an endpoint here, publisher of custom orders, get customer orders, return this.crm.get custom orders. Okay, so this would just be a regular HTTP controller. Okay, it's saying I need to provide beans of type web client and presumably the RSocket one as well, the RSocket requester. Thankfully, the recipe for both of those is fairly straightforward. We say builder.tcp localhost 8181. What did I say? Yeah, it was 8181, I think. Okay. And same thing here. We're going to build an HTTP client. And the client, you just call the builder. Okay, let's restart. Okay, so now if I go to curl HTTP localhost 9999/COs. Did I not have an endpoint here? Oh yeah. Okay. What's happening? Oh, where's my RSocket service? So RSocket localhost 8181, is that true for the RSocket service? 9191, aha. Okay, there we go. So there you go. So there's the data. You can see I've got the customer data and the order data in one fell swoop. So I can now see at a glance all the data. The client has no idea that this data came from a microservice over here doing HTTP, and this came from over here using RSocket. It just works, right? That said, this is only, the battle has been won here. We've successfully figured out how to capture, to transmit or to conduct that data in a way that the client can use. But what happens tomorrow when the client needs a new use case? Do you have to go back and build a new reactive HTTP endpoint or something like that? I guess you could. Certainly that's what a lot of organizations do. But what we want to do is instead make it easier so that a client can get the data they need in the shape they need it when they need it. And GraphQL is great for this kind of thing. So what we're going to do is we're going to go ahead and take advantage of GraphQL. Did I have this here? Yeah, I got GraphQL. Source main resources. I'm going to create a file here called GraphQLS schema.graphqls. And this is just GraphQL. Okay, so the schema in a GraphQL application describes the types and how they relate to each other. So type customer has an ID and a name. Type order has an ID and another ID for the customer, foreign key. And in, what we want to do is we want to support reading all the customers with their order data in line, okay? So the root type in all GraphQL applications is query. And here, we're going to say that we support returning a plural, that's this bit right here, a collection of customers, okay? So query is where you hang off all your HTTP endpoints, right, that you want the world to see. So put them in query, and you have these filters, these fields, rather, these accessors that are endpoints. So the customer data return 0 or 1 or more customers, okay? So let's now implement this using Spring GraphQL. We're going to introduce our final controller type for the night, a GraphQL controller. So CRM GraphQL controller, private final. What am I doing? Oh, okay. I'm doing message map. No, I'm query schema mapping. So the type that we're going to provide the implementation for is called query. And we want to describe a particular field. So the field is called customers. Okay, so publisher, customer, customer. Okay, customers. Return. We're going to use our CRM client here to do the work. So CRM.get customers. Okay. Okay, and then we want to get the order data. And remember, we want this order data to live on the customer, because that logically is where the data lives. It's just that for ease of implementation, and because of the fact that the data is spread across different services, we've just had two different sets of data next to each other. But really, I think of it as being customers, and the order data belongs to the customers. So I have a field here to resolve the orders for this particular customer. So I'll say publisher of orders. Now, of course, this doesn't actually belong to just by itself. It belongs to a customer. So I'm going to inject the root to that. I'll say return this .crm.get orders customer.id. Okay. So now let's see here. What does that give us? That gives us the orders data. So this is an n+1 problem. It's okay though, because it's reactive. It's still going to do n+1 connections, but at least it's concurrent. So you're not waiting to serialize, to get all the results in a serial fashion. Okay, so now I want to also enable a GraphQL console. True. So localhost 9999/graph-iql. Okay, and I get this nice tool I can use to introspect the data, right? So I want to get the customer data, great. I want the ID field. I also want the name field, great. What happens if I say I want the orders data? Well, it'll give it to me, but I need to identify it correctly. So you can see I'm actually adding to the response. I'm adding fields that I want to have returned back to me. And this is why one of the reasons why I love GraphQL. It was created by Facebook to give them an easy way to say, hey, if you want to use just this bit of data, great, just specify that in the query and we'll give you that data. But if there's other parts that you want, great, you can do that as well. But bear in mind, those might result in, as is the case here, a separate network call, a separate interaction. All right, my friends, well, I think we've looked at a number of different things that hopefully taken together should make your journey to production just that much more productive and fruitful and fun. Obviously, I hope this helps. I hope we got something out of it. I'm happy to answer any questions now. However, I said earlier I don't have to go anywhere. I'm actively tired, so if we can keep questions to like 10-15 minutes, and I'm happy to answer questions via Twitter afterwards, that'd be cool.
All right. Thank you so much, Josh. I think there was
My
one
pleasure.
question. There was one question. I don't know if you've already answered it, but it's said by Suresh. It says, "Is Spring Native supported only for GraalVM?"
Yes,
Okay.
good question.
I don't know if there's any other question from the audience, but I think this session has been really practical and then very educative. We will definitely,
Wonderful.
yeah, we will. Josh has actually given us the go ahead to record this session, so we will definitely upload the recording on our YouTube channel where anyone can watch again and follow along whilst building your application. So
I appreciate it.
Okay, there's another question.
Yeah.
Yes, by Godric. It says, "Is it a recommendation that all Spring apps now should move to native apps?"
No. But it is, if you can do it, it's a good trick to be able to do, right? But no, if you're happy with the app, then just leave it as is. It's fine. We don't care. Works well. But if you want, like for example, we have a project called Spring Shell. Spring Shell helps you build command line applications that has read line support and curses. You can do backtracking and tab completion. It's great, right? It's a CLI. It's a tool for building CLIs. It's a framework. It's a Spring Boot auto configuration for building a CLI. You can build your CLI using Spring Boot, and Spring Boot is basically Java. So you're running a JRE application. So in order to distribute whatever shell you end up building with Spring Shell, you'd have to ship the JRE, which is a little impractical. But if your users want to use Spring Shell, they can also do so using Spring Native. You can get native images out of that Spring Shell application. And the result is that now you can get binaries that work well on Windows, Linux, and Mac, and whatever, and you can distribute those. And now you don't need to bring down a whole JRE to run it. You just have a small little binary. So in this case, it's an obvious win to use native applications. But if it's not obvious to you, then don't use it. And it's not like the old way is going to go away or anything like that. It's just, I think it's a good opportunity if you're trying to reduce data center spend, if you care about startup time for serverless, etc.
All right. Again, so Josh is actually in a different time zone, so it's really we are really grateful for being here and sharing with us.
My pleasure.
This topic. So I guess everyone is fine, and there are no more questions. So guys,
well, I appreciate you all.
Yeah, I'll just encourage you all to share your takeaways with us on your social media channel, and then meet us next. Meet us next month for another session with the Jack Garnet.
Yeah, good idea. I'm Josh at joshlong.com. If you have any questions or find me on Twitter, I'm happy to help and carry the conversation forward. Thank you so much for having me. It was a pleasure, a privilege.
Yeah, thank you too, Josh. We hope to have you another time.
I'd be honored.
All right.
Good night, everybody. Or good afternoon, or whatever.
Yeah.
Bye.
Yeah, goodbye.